Okay, we're looking at the rational zeros theorem. So the number of real zeros, a polynomial function cannot have more real zeros than its degree. Okay, so for example, if you have a polynomial where the highest degree is x to the third, it cannot have more than 3 zeros. It can have less than 3 zeros, but it cannot have more than 3 real zeros. So in this rational zeros theorem, let f be a polynomial function of degree 1 or higher of the form f of x equals a sub n to the x to the n plus all the way down to the constant, where each coefficient is an integer. If p over q in lowest terms is a rational zero of f, then p must be a factor of a sub 0 and q must be a factor of a sub n. So basically, when we're looking at this, p is a factor of a sub 0. So we need to find the factors of the constant term. That's going to be our p. And q is our constant in front of our highest degree. Okay, so that is how we're going to list out our items. So in this example, we want to list potential rational zeros of f of x. So if we look at this negative 15 is going to be our p value. And this 3 is going to be our q. So if you think of the factors of 15, I know plus or minus 1 is a factor, and the other end of that factor would be 15, because 1 times 15 equals 15. I also know that 3 is a factor, so it would be plus or minus 3, and it would be 3 times 5, plus or minus 5. So our factors for 15 are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. All right, so we also need the factors of q, and q is going to be the number in front of the highest degree, which in this case is 3. So the factors would be plus or minus 1 and plus or minus 3. Those are going to be my factors. So now what we would want to do is we want to create our ratio. And that would be P over Q. And it's going to be every P over every Q. So the first one would be 1 divided by 1. So plus or minus 1 divided by 1, which we could rewrite that as just plus or minus 1. Okay, our next factor would be, and just go in order. We did 1 over 1, so now we want to do 1 over 3. So it would be plus or minus 1/3. And then you're going to do this for each of the factors. So you're going to start on the next one. 3 divided by 1 is 3, so plus or minus 3. 3 divided by 3 is 1, and we already have plus or minus 1 listed. So that means we don't need to list it a second time. So what I'm gonna take this part and erase this right here. And what I'm gonna do is down here, I'm gonna list that would have been plus or minus 1 over plus or minus 1. And then we also got this by 3 divided by 3. Okay? And then the next one would be 5 divided by 1, so that would be plus or minus 5. 5 divided by 3 would be plus or minus 5/3. 15 divided by 1 would be plus or minus 15. And the last one, 15 divided by 3 is 5, which is listed up here because we did 5 divided by 1, and we also did 15 divided by 3, and both of them give us 5, so we only need to list it one time. So basically, when we look at this, we have 1, 2, 3, 4, 5, 6, and there's 2 signs for each one. So 6 times 2 equals 12. That means we have 12 potential factors, or 12 potential rational zeros. So once again, these are my potential rational zeros.